Hi everyone, welcome back to my geometry tutorials. Today I'd like to go over slopes. The slope of a line passing through points x1, y1, and x2, y2 is given by rise over run, which is y2 minus y1 divided by x2 minus x1. So slopes are actually associated with coordinate geometry and in particular with Cartesian coordinate systems. So you might have seen this already if you've done Algebra 1. Cartesian coordinate system, you have an x-axis, you have a y-axis that's perpendicular to the x-axis, and you have an origin, right? Point 0, 0. So the important thing to know is that in a Cartesian coordinate system, each point can be represented as an ordered pair, x1, y1. So what is an ordered pair? Well, point 0, 1 is different than point 1, 0, right? Because the ordering matters, right? These are different points, right? This is point x is equal to 1, y is equal to 0, and this is point x is equal to 0, y is equal to 1. So just try to remember Cartesian coordinate system is made up of all these different points where you have an x-coordinate and a y-coordinate, and the order in which it's placed is going to make a difference. So let's actually go on here. I'm actually going to do more videos on coordinate geometry later on. For right now, I just want to stick to these two theorems because they're going to be related to our work on quadrilaterals and triangles. So the first theorem is non-vertical lines are parallel if and only if they have equal slopes. So this is an if and only if statement. It's a biconditional. If you want to go back to one of my original videos on indirect and direct proofs, I think I talk about biconditional. So it means basically the statement works in both directions. So in other words, if non-vertical lines are parallel, then they have equal slopes, and also if two lines have equal slopes, then they are parallel. So just try to think of an if and only if statement like that. Theorem 2, non-vertical lines are perpendicular if and only if the product of their slopes equals -1. So I'm just going to go ahead and do some problems where we apply these theorems, and you'll see how they work. So we're given this quadrilateral, right? A, B, C, D in a Cartesian coordinate system, and then each point is represented by its x-coordinate and y-coordinate, right? And I want to prove that this quadrilateral ABCD is a parallelogram. So we know that a parallelogram has parallel opposite sides. Well, if we go back to theorem 1, we know that non-vertical lines are parallel if and only if they have equal slopes. So what we can do is, since we know the parallelogram has parallel opposite sides, well, let's compute the slope of line AB and its opposite side, line CD, or segment CD actually, but so let's do the slope of line AB. So we use the formula y2 minus y1 divided by x2 minus x1. So we take 6, which is y2, minus 5, which is y1, divided by 5, which is x2, minus 2, which is x1. And then we get the slope of line AB is equal to 1/3. If we apply the same process to line CD, well, we get 2 minus 1 divided by 4 minus 1, and that's 1/3. So the slopes of these lines are equal, and since the slopes of the lines are equal, then the lines are going to be parallel. So line AB is parallel to line CD. And then remember in the parallelogram, you have two pairs of parallel opposite sides, right? So we got to do the same thing for line AC, line BD. So the slope of line AC is gonna, we use the same formula. So 5 minus 1 divided by 2 minus 1, and that's 4. And then the slope of line BD, we do the same thing. So we're going to get 6 minus 2 divided by 5 minus 4, and that's equal to 4 if you work out the arithmetic. So since slope of line AC is equal to slope of line BD, line AC is parallel to line BD. So in this case, this quadrilateral ABCD has two pairs of parallel opposite sides, so it is a parallelogram. Just as a reminder, if you only had one pair of parallel opposite sides and the other two sides were not parallel to each other, then it would be a trapezoid, right? Okay, so let's take a look. So we have this Cartesian coordinate system. We have triangle ABC, and we're given the coordinates right here. And so I didn't actually put down, well, this is the x-axis and this is the y-axis right over here. So we want to prove that triangle ABC is the right triangle, and we want to determine which of these sides is going to be the hypotenuse. So we're going to go back, we're going to use theorem 2. Non-vertical lines are perpendicular if and only if the product of their slopes equals minus 1. So we know a right angle occurs when lines meet, when perpendicular lines intersect, right? So, and then we can use slopes to determine if lines are perpendicular. So let's do slope of line AB. So we use the same formula. So we get 2 minus 4 divided by 3 minus 2, which is going to be minus 2. And the slope of line BC is going to be 3 minus 2 divided by 5 minus 3. And that's going to be 1/2. So what happens when you multiply slope of line AB with slope of line BC? Well, you get minus 2 times 1/2, and that simplifies to minus 1. So in other words, we know that line AB is going to be perpendicular to line BC. So in other words, angle ABC is a right angle because perpendicular lines meet at right angles, right? So, and we know that a triangle with a right angle is a right triangle. So we just proved that ABC is a right triangle. Remember, the hypotenuse of a right triangle is the side that's opposite the right angle. So we know that the right angle is ABC. So the side opposite the right angle is going to be side AC. So side AC is the hypotenuse for triangle ABC. Okay, so this last problem here, we're given square ABCD, so we don't have to prove that. I'm just going to tell you that it is a square. We're not going to prove that it's a square. But we are going to prove that diagonal AD is perpendicular to diagonal BC. So remember, diagonal is a segment joining two non-adjacent vertices in a polygon, and four-sided polygon's quadrilateral. So I'll talk more about polygons later. So just remember that they're non-adjacent, right? The adjacent vertices to A would be B and C, and adjacent is just a fancy way of saying next to. So let's so we want to determine if these diagonals are perpendicular. So let's go back to theorem 2. Non-vertical lines are perpendicular if and only if the product of their slopes equals minus 1. So let's determine the slope of line AD. So we use our formula here. So 3 minus 4 divided by 5 minus 2, and that's equal to minus 1/3. And the slope of BC, of line BC, is going to be, we use the same formula of 5 minus 2 divided by 4 minus 3. And then when we simplify, we get 3. So if we multiply the slope of line AD with the slope of line BC, we get minus 1/3 times 3, which is equal to minus 1. So in other words, we know that line AD is going to be perpendicular to line BC. So, these are segments, right? And they're subsets of lines. So we know that diagonal AD is going to be perpendicular to diagonal BC. And that's a property we proved. Remember, all squares are rhombuses, and we proved in one of the last videos that a rhombus has perpendicular diagonals. So this is just like a verification of that using coordinate geometry. So this is a short video today. I think this one's a little bit more computational. So I hope you enjoyed this video. I will be making more videos, of course, and I hope to see you, when I make my next video. So have a great day, everyone. Bye.